In this video, we're going to talk about how to find the domain and range of a function where we're looking at the graph of the function. Okay, so first, we know what domain is. It's the value of the x's that are allowed to go into the function. So what is range? Range is the set of y values that come out of a function. Okay, so it's basically if f of x equals y has at least one solution, then that y is part of the range. Okay, so let's go ahead and first we'll find the domain. We're looking at this example here. So domain, the values that x is allowed to take on. This graph, so when we're thinking about domain, we need to be thinking in the x-axis terms. Okay, so when we're looking at what values it does, does this graph take? Well, you see these arrows indicate that this graph keeps on going, and so it gradually keeps on going. So it's eventually going to reach all real numbers. And same thing over here. It's going to eventually keep on going, and it's going to reach all real numbers in both directions. So the domain for this graph is negative infinity to infinity. So now let's do the range. So when we're thinking about range, we need to think about in the y-axis, what values are seen here in the y-axis, and we see that we continue going up forever, so all the way to infinity, but we don't ever go below -2. So we go down to -2, and then we go up. So the range starts at -2, and it includes -2, because -2, there is a point there, but then it goes all the way to infinity. So that would be the range. Okay, let's do another range and domain example. So first we'll start with domain, and then we'll do range. So let's look at this. Thinking about domain, what values of x go into this function? Okay, this is kind of a crazy looking function here, but by looking at the graph, we can still determine the domain. So first thing, let's see. What's the smallest value of x? So first off, you don't see any arrows at the end, so it doesn't continue going. It stops there. So the lowest value that x goes to is -3, right? It doesn't ever get lower than -3. So, and it includes -3 because there's a dot. There's a solid dot there. And then if I were to go over on the other side as I continue going, the lowest x, or the highest x ever becomes is +3. And it doesn't include +3 because there's an open circle there. So this would be +3, and there'd be a parentheses, soft parentheses. Okay, so now let's do one more thing about the domain. We need to make sure that as we're going along that every x value is included between -3 and 3. So if you were to look across, you see at one point we jump, but we pick right up where we left off, and so yeah, every value of x between -3 and 3 is shown here in this graph. Okay, if you were to have jumped earlier and then there would be some values missing, you'd have to take that into consideration when you're thinking about the domain. Alright, so now let's talk about the range. So here in the range, we're looking in this direction, and so I always start on the negative side. What's the lowest the range becomes? Okay, I see here the range is at lowest, it's -1. But it goes straight across a -1, so even though this one is not included here, this point is still -1, so y does actually observe observations at -1, so we do include -1. Okay, and then if I were to go up from there and to find the highest I ever reach, you see here at 3, that's the highest my y values ever reach. So at 3, and I do include it because there's a solid dot there. Again, you need to check that all the values between -1 and 3 are observed, because if there's a jump, then you would have to take that into consideration when you're writing your range. So if I go up, yeah, there's all these values of -3, and then there's all these values here. So all these values And then when I go over, there's all these values. So there's there's values of x for all the values between -1 and 3.